Today is 10-5, and we're going to look at the intermediate value theorem, and we're still in the unit of limits and continuity. So the intermediate value theorem is our second existence theorem, and here's the definition. It states, for any polynomial function with real coefficients, suppose that if a doesn't equal b, so your two x values can't be the same, and p of a and p of b are of opposite signs, meaning one's positive and one's negative, then the function has at least one real zero between those two x values. Now remember, the intermediate value cannot be used to determine whether there is a real zero between a and b when p of a and p of b have the same sign. So let's unpack this just a little bit, and then we'll kind of practice to show you what it means by the definition. So what does it look like? Well, if we have our x or y graph here and we have 2 points, what it's saying is that if one is positive, so in this instance this one is positive, and then one is negative, in that instance that's negative, it has to cross the x-axis. There has to be a zero in between there. There's no other way to do it because our function is continuous. And so the intermediate value theorem just says that within that interval, you know that it's at least going to cross the x-axis once. Now, we have to be careful of a few assumptions about the intermediate value theorem. So we have to be careful about these. The first assumption is some of us think, well, if it crosses, there's only one zero. And that's not true. The definition says at least one zero. And what I mean is your function can do this. Well, this is positive, this is negative, and so if you noticed, it crossed a bunch of times, definitely more than once. So we have to be careful about that. You can't say there is one zero, you just know there's at least one zero. The other bad assumption is when the signs are both positive or both negative. Sometimes we assume, oh, there is no zero between there, and that's also a false assumption, because your graph can do its thing and then go back up into the positive direction in this instance, but notice it crossed the x-axis a bunch of times in between, but yet they're both positive. So just remember, when the signs are different, there could be more than one zero in between. We just know there's at least one. Second, if they're both positive or both negative, you can't assume that there aren't any. We just may have to do other things to try and figure that out. So here's a couple of examples. It says use the intermediate value theorem to determine whether the function has at least one real zero between a and b. So we have to evaluate. So I plug in -4 and I plug in -2 and I simplify it. And so I got -24 and 8. Well, since the signs are different, I can conclude that at least one zero exists between a and b. It could be 2, could be 3, but I know at least a zero exists between a and b. What if I chose the interval -1 and 3? If I plug those in, this is positive and this is positive. Now remember, we cannot conclude and say, oh, there's nothing in between. We can only say that we can't, with this information, we just don't know, right? There could be a zero in between, but right now with this information, we just don't know if there is one or not. Now let's conclude the lesson. Now what does the intermediate value theorem tell us? Well, it says that for two different x values, if one of the y values is negative and one of the y values is positive, you can make the assumption that there's a zero in between those two x values, because it has to cross the x-axis to get to that other y value, right? For it to go from positive to negative, it has to cross the x-axis. For it to go from negative to positive, it has to go across the x-axis. Now, a few bad assumptions that we can make, and we have to be careful of it. The first, if their signs are both the same, we cannot assume that there is no zero. There still might be, we just can't assume it. and we may have to use other algebra techniques to determine if there is a zero in between. The second is we can't assume that if the signs are different, that there's only one zero. There could be multiple zeros in between that interval, and we would have to use other algebra techniques to determine that. This does conclude our lesson. If you have any other questions, please leave them in the comments.